Hello everyone and welcome back to our Data Structures with Python lectures. In the last few weeks we worked with singly linked lists and realized that they are made of a collection of nodes that are linked together, hence the name linked list. Each node had two pieces of information in it, one of them being a variable that contains the data itself of the node, and we called it data. It can be anything. It can be an integer, a string, a character, anything that you want it to be. And the next piece of information that it had was a pointer that we called next. The next pointer is always going to point towards the next node in our linked list. So today we're going to start working with doubly linked lists. And the first question should be, what is a doubly linked list? Well, mainly a doubly linked list is a singly linked list with one additional pointer. So we still have data, we still have our next, but now we have another pointer that is called previous. That means that the nodes in here, the nodes in the doubly linked list, know not just what is right after them or what's next to them, but what is right before them or what is previous to them. We still have the head in here. Previously, we said that some programmers would use tail as well. With doubly linked lists, you can use tail as much as possible. And that is because since I know the next, I can go from head to the next, and finish. And at the same time, I can go from the tail to the previous, and then finish. So a doubly linked list is actually bidirectional, which means it goes in two ways. It can go from left to right or from right to left. And that is one of the main differences and one of the main advantages that it has over simply linked lists. So from this shape that we're seeing in here, this simple example of a doubly linked list, you can see that we can start at the head, then go to next, jump to the next, and finish, or we can go the other way around. Now, since we have two pointers in every node, previously we only saw next equal none at the last node. So right now you can see that if I start at head, by the way, this is the first and this is the last because I have head, which is first, and tail, which is last. And it's the same. Next is none in the last node. But at the same time, in here we have something new. Previous equals none in the first node in our list. So from now on, whenever we see a previous with a none value in it, that means we are at the first node in our doubly linked list. And if we see none at the next pointer or as the value of the next pointer, that means we're at the last node in our doubly linked list. So we have some advantages for doubly linked lists over simply linked lists, and it's very, very simple. One, we can traverse the list in both directions. We just talked about this. We can go from left to right or from right to left. Two, it needs less iterations to delete or to remove a node than a singly linked list. Now, if you go back to this example in here, when we deleted a node or removed a node in a singly linked list, we needed two pointers. One of them was the current. Let's say I want to remove this node in here. So I need a current that is going to point to it, and I need another pointer called previous to point to the node right before it. And the main reason behind it is because I want to say the next of the previous equals my next, so that I can make the pointer goes from here all the way to here. But when we are looking at this example right now, we can see that the same node, the current node, actually knows what is right before it or previous to it. So in here we can say something like node.previous.next equals node.next, and that is going to make this pointer point here because we're saying the node, look, node.previous.next. So the next that is related to the node that my previous is looking at equals node.next, which is this location. We are pointing to it. And that makes deleting much easier. Because of that, there is another advantage, which is we can delete a node directly without traversing. We said with singly linked list that if you want to insert or if you want to delete or remove, you always have to traverse. But with doubly linked lists, if someone gave you a pointer to a node, if someone actually gave you a node, you can delete it. You don't need to traverse. And that is because, let's say we take this. Someone gave us this pointer in here. Let's say that the tail is the pointer, and I want to delete this. I don't need to come to the head and start to traverse all the way here. No, I can just delete it, and I can say previous tail.previous.next equals tail.next, which is none. And if I put none in here, this is deleted. Again, when we are going to work with inserting and deleting, we're going to customize our singly linked list program to make it work with doubly linked lists. And it is going to be super simple because they are almost the same. So don't fret about it, don't think about it. All I need from you right now is to open your Python programs for the singly linked list, because we're going to start working on programming the doubly linked lists in the next lecture. I'll see you soon.